In this session we're going to be solving inequalities. So an inequality looks something like this. You could have a greater than or a less than, but then we also have greater than or equal to and a less than or equal to. So if I have x is greater than 4, what this is saying is that on a number line, here's 0, and here 1, 2, 3 is 4, that x is all numbers that's greater than 4. So it's not actually 4, it's not equal to 4, so I can leave an open circle there, but it's all the numbers greater than 4 and becoming infinitely close to it, but not actually hitting 4. If now I have x is greater than or equal to 4, this greater than part now allows me to include 4. So I would shade that in to signify that I'm including it. Another way to write this is, instead of using shading methods, if we're including 4, often you will see this, a bracket, to in this direction, signifying that it's going this way. If it was back to the greater than 4, then we'd use a parenthesis in that direction to indicate that it's going this way, but it's not actually including 4. So now let's try solving one. Let's say I have 2x plus 3 is greater than, let's say, 9. Now, to solve these, it's really not that hard at all. It's just like doing an equation, except there's one extra thing. Anytime you divide or multiply by a negative number, you do everything the same, but you also flip the sign. So if we had a greater than, it would become a less than. If we had a less than or equal to, it would become a greater than or equal to, and so on. So back to here. If we want to solve for this, first we're going to start out by subtracting 3 from both sides. Now we have 2x is greater than 6. Divide both sides by 2. We get x is greater than 3. So in this situation, we didn't have to worry about dividing or multiplying by a negative number, but we will later on. Now, if x is greater than 3, that is my solution. But there's another way to write this solution. It's called interval notation. So what interval notation is it has a number. It shows a range of solutions. So again, in our number line, here's 0, and here's 3. X is greater than 3, so I'm going to have a parenthesis there and signifying that it's going that way. So in interval notation, my solution set starts at greater than 3 and it goes all the way to infinity, all numbers greater than 3. So I'm going from 3, comma, which signifies my 2, infinity. Now anytime we have infinity or negative infinity, we put a parenthesis by it. And then just like before, if we're including the number, we use a bracket. If we're not including it, we use a parenthesis. So again, greater than, strictly greater than, not including 3, not equal to 3. So we're not including 3, so we'd have parentheses on both sides. This would be our solution in interval notation. Now let's say we have negative y minus 4 is less than or equal to 6. Now to solve for y, we're going to start by adding 4 to both sides. So we get negative y is less than or equal to 10. And then again, we're not solving for negative y, we're solving for positive y. So we're going to divide both sides by a negative to cancel that. Now we have y. But remember, when multiplying or dividing by a negative, we switch the sign. So this is now going to be greater than or equal to, and then 10 divided by negative 1 will be negative 10. So we do everything the same, it's just that in addition to that, we flip the sign when we divide or multiply by negative. So now we have y is greater than or equal to negative 10. So on a number line, here's 0, let's say here's negative 10. Greater than or equal to means we're including the 10, so we'll draw a bracket in this direction. In interval notation, you can think of it as going from left to right. We're not hitting the graph, not hitting it, and then here we are. So we're going from negative 10 all the way to infinity. Anytime it's infinity, we have parenthesis. If we're including the negative 10, which we are, we put a bracket, and this is the solution in interval notation.